Welcome, dear learners. Today we'll be taking a look at how to use determinant method to solve simultaneous equation. In our last video, we have discussed how to find determinant of a matrix. Then the knowledge is what we are going to be using here. We have two pairs of simultaneous equation here, so we shall be taking a look at it. Starting from the first one, to solve simultaneous equation like this using determinant method, we first turn the coefficient of the variables into a matrix. Let's say the matrix become, let's say matrix A, we then become, what's the variable? We have 2 minus 4, 5, and 8. We have turned this to matrix now. Let's not forget, what is the formula if we are solving simultaneous equation using determinant method? Remember, in our simultaneous equation, we always look for the variable x, y, a, b, depending on the situation. So for the variable x, our x will be equals to determinant of variable involving x all over determinant of the matrix, and y will be equals to determinant of the one involving y all over determinant of the matrix. Now, the matrix A here is gotten from the coefficient of the variables here. So this is the determinant of this matrix. So determinant of this matrix, that is this one, is equals to, now how do we do this? We multiply this diagonal, that is 2 multiplied by 8, that's 16, minus, then this one will give us minus 20, minus times minus, that gives us plus, as 20, then this one gives us 36. So 36 is the determinant of this matrix. Now, how do we get this one, determinant of x? That is for x. When we are looking for x, what do? We change the part of x. This part, that is the part of x, we switch this into it. Then it becomes 4, 3, minus 4, 8. What have we done? We've substituted the part of x here, which is 2 and 5. We have substituted the outcome here into that part, so as to determine the determinant of the part of x. So determinant of the part of x will be equals to, we do this one, 4 multiplied by 8, that is going to give us 28. That's 28 minus, we multiply this as well, the diagonal, that's going to give us minus 12. So it then turns to plus 12. So closing this gives us 40. So determinant of the part of x is equals to 40. We do the same thing for y, that is for y, we change it. You can try that before I proceed. Okay, yes. So you substitute this for the part of y, then it becomes 2, 4, 5, 3. Great. So we then find the determinant of the part of y, which is this diagonal, that's 2 multiplied by 3, that's 6, minus 4 multiplied by 5, and that is what? That is 20. So at the end of the day, we have minus 14. Now that we have that, we can then say our x is equals to determinant on the part of x all over the general determinant, which is equals to determinant of the part of x, that's 40 all over 36, which that one becomes 10 all over 9, which in turn becomes 1 whole number 1 all over 9. Now for the part of y is equals to determinant of the part of y, all over the general determinant, which is equals to, what is the determinant on the part of y? Minus 14 over determinant, the general determinant, which is 36. That becomes, can we reduce this further? Maybe let's start minus 2 goes here, 7, 2 goes in 36, that gives us 18. Therefore, our x is equals to 1 whole number 1 over 9, and our y is equals to minus 7 all over 18. So those are the two values for the two variables that we have here. Let's take a look at the second one. The second question says 6a minus 5b is equals to 20. 4a minus 3b is equals to 7. So let's solve that gently now. Remember the first step, we have to turn the coefficients of the variables, we have to turn it into a matrix. That gives us 6 minus 5, 4 minus 3. So we determine the determinant of this matrix, which is this one. We multiply this diagonal, that gives us minus 18, minus, we multiply this diagonal, that is minus 20. No, minus 20 working on this, that will give us plus 20, and in everything this is going to give us determinant of what? Determinant of 2. Moving on the part of a now. For a, we turn it to matrix. We take coefficient of a, we replace it with what we have here, 20 and 7. That means we have 27 minus 5 minus 3. So determinant on the part of a will be equals to, we multiply this diagonal, that's minus 60 minus, when we multiply this diagonal, that gives us minus 35. So that will give us minus 35, and if that operates, that becomes minus 60 plus 35. Then the determinant on the part of a will be equals to minus 25. Now for b part, for b, what do? We change the coefficients of b, we substitute it with the outcome here. That becomes 6, 20, 4, 7. We close it. We find the determinant on the part of b. The determinant of the part of b, we multiply this diagonal, 6 multiplied by 7, and that gives us what? 42, 4, 2, minus, we multiply this diagonal, 20 by 4, and that gives us 80. Therefore, it becomes 42 minus 80, that gives us 38 minus 38. So determinant of b is this. Now recall that a is equals to determinant on the part of a all over the general determinant, which is equals to determinant on the part of a is minus 25 over the general determinant, which is 2, and that gives us, we have minus 12, 1 over 2. On the part of b, determinant of the part of b over the general determinant, which is minus 38 divided by 2, and that gives us minus 19. Therefore, A equals minus 12 1 over 2 and B equals minus 19. And we have simply been able to solve the given simultaneous equations using the determinant method. If you enjoyed this, subscribe to our channel, Demmy Academy, like the video for more interesting learning experience. Till see you next time, math is fun.